Welcome back to Tales of Chemistry. Today, let's see a very small topic in ICSE 10 Standard Chemistry, percentage composition. In fact, you have studied this in 9 Standard, so this will be a quick revision. Now, what is percentage composition? It is the percentage by weight of every element, each element present in the compound. It is the percentage by weight of every element present in the compound. All right. And percentage composition is equal to, or it is calculated as weight of element in one molecule of the compound by GMM, gram molecular mass, which is nothing but the molecular mass expressed in grams of the compound into 100. So, weight of the element in one molecule of the compound by RMM expressed in grams into 100. Now, when we solve some examples, it will be clear. So, the first question here is, calculate the percentage by weight of potassium in potassium dichromate. So, first of all, we need to calculate the molecular mass of potassium dichromate, GMM, molecular mass, or you can even write RMM, but keep the unit grams of K2Cr2O7, potassium 2 into 39 plus chromium 2 into 52 plus 7 into 16. So when you solve this, okay, you are getting this as 78 plus 104 plus 112. So that is equal to 294 grams. All right. Now, percentage of potassium in K2Cr2O7 is weight of potassium in K2Cr2O7 by GMM of K2Cr2O7 into 100. That is 2 into 39. It is K2, right? 2 atoms of potassium are present. So 2 into 39, 78 by 294 into 100. Now you will have to solve this. On solving, your answer is 26.53. Keep the answer up to the second decimal place. So 26.53% of potassium is present in potassium dichromate. Next one. Phosphorus in calcium phosphate. Formulas given, Ca3PO4 twice. If you are confused, you can open the bracket and write that is Ca3P2O4. That way also you can write and find out the molecular mass. Calcium is 40, so 3 into 40. Which is 120. Phosphorus is 31. 2 into 31, that is 62. O4, 4 into 16, that is 64. So when you add this, O8, it has to be, sorry, O8. So another 64 is to be added, all right? So when you add this, your answer will be 310 as in GMM of calcium phosphate is equal to 310. Okay, now percentage of phosphorus in Ca3PO4 twice is weight of phosphorus in that compound by RMM or GMM of calcium phosphate into 100. That means P is present 2 times, right? So 2 into 31 into 100 by 310. Okay, so this calculation was easy. 31 and 31 is cancelled. So this gives you exactly 20% of phosphorus. So such simple questions you can find in MCQs, yeah, which is very easy to solve, will appear or can appear in MCQs. Now, calculate the mass of nitrogen supplied to the soil by 5 kilogram of urea. So this is a slightly different one. Calculate the mass of nitrogen supplied to the soil by 5 kilograms of urea. So first of all, what is the molecular formula of urea? CONH2 twice. Then GMM of urea, gram molecular mass of urea. C is 12, oxygen is 16, nitrogen 14 into 2, so 28, and 4 hydrogens. So add them together. This will give you 60 gram molecular mass of urea is 60. Now look at the statement. 60 grams of urea contains, I've just put an arrow to represent contains. You can write in words also. 60 grams of urea gives you, or it contains 28 grams of nitrogen. On what basis have I written 28 grams? There are 2 nitrogens. Each nitrogen's weight is 14. So 60 grams of urea gives you 28 grams of nitrogen. But my question is in kilogram. So what I will do is this 60 gram, I will convert it in kilogram. 60 kilogram of urea gives us 28 kilograms of nitrogen. Right, no? 60 units is giving me 28 units. So 60 kilogram will give me 28 kilogram of nitrogen. Therefore, 5 kilogram of urea gives me X kilograms of nitrogen. To solve for X by unitary method, 5 into 28 divided by 60. Okay, 5 into 28 by 60, which will be, this can be taken as 12, 28 by 12, that is 14 by 6, 7 by 3. 2.333 kilograms of nitrogen. Okay, so 5 kilogram of urea will give us 2.333 kilogram of nitrogen. It's a recurring decimal. Keep it at least up to the second decimal place. Now, the next question is calculate the percentage of water of crystallization in washing soda. So total percentage of water is to be calculated anyway. First of all, let us go for GMM. GMM, sodium is 23. So 2 into 23 plus C is 12, oxygen is 16, 3 into 16. Each water molecule's weight is 2 plus 16, that is 18. 10 water molecules, so 180. Now, this will be 46 plus 12 plus 48 plus 180. That is equal to 286 grams. So your statement is gram molecular mass you got, right? Percentage of water or water of crystallization in washing soda. Percentage of water of crystallization in washing soda is weight of water in washing soda by GMM of washing soda. I'm just writing WS into 100. That is, weight of water is 180. 180 into 100 by 286. Yeah, when you solve this, you will get around 62.94%. 62.94% is the answer. This is the percentage of water of crystallization. Percentage of water of crystallization in washing soda. Now, moving on to the next one. Percentage of pure iron in 10 kilograms of Fe2O3 of 80% purity. Again, a slightly different question. The atomic mass of iron is 56. Now, first of all, 10 kilogram of Fe2O3 is only 80% pure. In 10 kilogram, 80% is Fe2O3, 20% is some rubbish. So we don't need that 20%. So what is the 80% of 10 kilogram? 8, isn't it? 80 by 100 of 10 kilogram. Okay, so that is equal to 8. So here 8 kilogram is pure Fe2O3. Now, percentage of pure iron in Fe2O3, GMM of Fe2O3 is to be calculated. That is 2 into 56 plus 3 into 16. 2 into 56 plus 3 into 16, that gives us 160. Now, 160 gram of Fe2O3 has Fe2, 2 atoms of Fe, right? So 56 into 2, that is 112. 112 grams of Fe. But the other weight is in kilogram. So I will convert or change this into kilogram. If 160 gram gives me 112 gram, definitely 160 kilogram of Fe2O3 should give me 112 kilogram of Fe. All right. Therefore, 8 kilogram of Fe2O3 should give me X kilogram of Fe. Again, by unitary method, solve for X. 8 into 112 divided by 160. Okay, so 20, 56, 5.6 kilogram. 5.6 kilogram is the weight of, what do you say, iron. Yeah, 5.6 kilogram is the weight of iron. But what is the question? Percentage of pure iron. Right, so here Now, percentage of Fe is equal to weight of Fe by total weight of the compound into 100. What is the weight of Fe? 5.6. What is the total weight of the compound? 10 kilogram, the impure one. Okay, 10 kilo. Total weight is 10 into 100. So that makes it 56% of pure Fe is present. Okay, this was a slightly difficult one. You can listen to this method solution twice or so, you will understand it. The next question. Now, let us see this question. Find the total percentage of oxygen in magnesium nitrate, hexahydrate. So, the weight of magnesium is given 24. First of all, GMM has to be calculated. The formula is MgNO3 twice 6H2O. GMM of magnesium nitrate, magnesium 24 and nitrogen 2 into 14, that is 28. Oxygen 16 into 6, 96. And water, each water molecule is 18. 18 into 6 is 108. So just add them together. 24 plus 28 plus 96 plus 108 is 256. Total percentage of oxygen is calculated as weight of oxygen in magnesium nitrate by GMM of magnesium nitrate into 100. Weight of oxygen, there are totally 12 oxygens. NO3, O3 twice, so that makes it 6. And again here 6 water molecule you will find, 6 more oxygen. So totally 12 into 16 into 100 by 256. So let's do it. 12 into 16 into 100 by 256 is exactly 75%. Now, the next question. Percentage of boron in borax. Borax formula is given Na2B4O7. So carefully let us calculate the GMM. Na2, so 2 into 23 plus B4, 4 into 11, O7, 7 into 16, then 10 molecules of water, that is 180. Let me do this now. 2 into 23, that is equal to 46, and the other one is 44. And then you have 7 into 16, which is 112 plus 180. Let me add it. 46 plus 44 plus 112 plus 180. This is equal to 382. Percentage of boron. So, percentage of boron in borax is equal to weight of boron in borax into 100 by GMM of borax. What is the weight of boron? 44. 4 into 11. 44 into 100 by 382. 44 100 by 382 is equal to 11.5%. 11.518 percent is the exact answer, 11.518%. Now, next one, percentage of water of crystallization in blue vitriol. So step number 1, GMM of blue vitriol. Blue vitriol is CuSO4.5H2O. Okay, so Cu is 64, S is 32, O4 again 64, and 5 water is 90. Let's add them together. 64 plus 32 plus 64 plus 90, that makes it 250. Now, percentage of water. Percentage of water is equal to weight of water into 100 by GMM. Actually, weight of water in blue vitriol. So that is 90 into 100 by 250. So on calculation, 90, 100 by 250 is equal to 36%. So this question answer is 36% of water of crystallization is present. Now, one last question for now. And this is a different question. If a crop of wheat removes 20 kilogram of nitrogen, so every time that crop is over, it is taken, you have the soil loses 20 kilogram of nitrogen, which means you will have to give back that 20 kilogram of nitrogen per hectare of soil. But read the question, you have 10 hectares of land, which means what you will have to give back to the soil is 200 kilograms of nitrogen. But which is the fertilizer that you are using to give back this 200 kilogram of nitrogen? You are using calcium nitrate. So step 1 is GMM of calcium nitrate, that is 40 plus N2, 28, O6, all right. So that is 6 into 16, 96. And on adding 40 plus 28, 68 plus 96, 164. Now, 164 grams of calcium nitrate gives you 28 grams of nitrogen, which I can write, therefore 126 kilogram of calcium nitrate gives you 28 kilogram of nitrogen. But here you will have to take X kilogram of calcium nitrate so that you will produce 200 kilograms of nitrogen. You need to give back to the soil 200 kilogram of nitrogen. Yeah. Now, cross multiply. So X is equal to 164 into 200 by 28. Let me solve this. 164 into 200 divided by 28. That is equal to 1171.42 kilograms. Okay, so 1171.42 kilogram of calcium nitrate is required as fertilizer for my 10 hectares of land. Yeah, so these are the important questions from percentage composition. If you study this type of question, that is enough even for your board examination. Thank you for watching and stay tuned for more videos.